Okay, you guys, we're back for 10-114 and 10-116. I've combined 2 days work into 4 problems, and just getting down to business of what's really important here. For 10-114, what we are doing is we're looking at what happens as geometric series get really big. Okay, and so they've given us 2 examples in 10-114. The first one is 200 plus 100 plus 50 plus ... plus, and then they were nice enough to give us the explicit equation. And here's our second one for B, 16 plus 24 plus 36 plus ... plus. Okay, so they've given us these 2 to kind of mess around with here and see what happens when we go really kind of far out into the sequence. What we're going to do is we are going to plug in n equals 10 and n equals 30, and something very interesting will happen. Okay, so I have I'm finding the sum, by the way. So I'm finding the sum out to 10 numbers and then finding the sum out to 30 numbers. So if you remember, the sum formula is t of 1 times r. Okay, so notice they gave us r. We could have also found r by doing 100 divided by 200, which is 1/2, to the n. So we're doing 10 for this problem, minus 200 over r minus 1. Okay. 200 times 1/2. No, I'm going to do that differently. 200 times 1/2 to the 10 minus 200. You guys can put 0.5 there and eliminate the need to do that. 1/2 minus 1. Okay, so I have 399.6. Okay, I want you to notice that this is really close to something. Okay, so now what I'm going to do is the same thing, but I'm going to do 30 terms out instead of 10 terms out. Sum equals 200 times 1/2 to the 30 minus 200, no, minus 1. Okay, so now we're going to be a little bit lazy, just a little. And we are going to go change that to a 30. And look at how interesting that is. So one, two, three, 4, 5, 6. Okay. What I want you to see here is that because the number keeps getting smaller and smaller each time, so 25 and then 12.5 and then 6.25, this sum actually approaches a number. Can you guys tell what number it is approaching? Okay, great. Okay, now this one is a little bit different, so I'm going to do sum equals 16 times 3 over 2 to the 10 minus 16, 3 over 2 minus 1. hear my dog in the background. She is very annoyed with the fact that we are not playing right now or taking a walk or anything that she would like to do. So she's walking around and sighing and then laying down. Okay, so 1813.3. Let's go with that, okay? It's kind of interesting. It doesn't really show us a clear number like 400 here, so let's try again with 30 and see if we get any more information. Okay, again with my laziness or efficiency factor here. Okay, notice this one just keeps getting bigger and bigger and bigger. It's not approaching a number. It's just getting bigger. Why is that? Well, that's because the numbers keep getting bigger as the series goes up. This one, the numbers keep getting smaller. This one, the numbers keep getting bigger. Okay, so we can write a rule for that. Notice the multiplier here, so if multiplier r is less than 1, then a sum exists, which means that I can tell that it's approaching a number. And if the multiplier r is greater than 1 as this one, so this is 1/2 and this is 1 and 1/2, then no sum exists. And what that means, it doesn't mean that a sum doesn't exist. It means that if you went forever, the sum goes to infinity. That is not my best infinity symbol. Okay, so the question is, and this is going to be 10-116, notes, infinite geometric series. Okay. Okay, so we are going to show both of these, and what I want to show you is how do I get this 400 here without having to like plug in different numbers of n and see what it's approaching. Okay, so we are going to do example 1 and example 2. Example 1, I know is going to be crazy. It's going to be this one. And example 2 is going to be this one. Okay, so example 1 is you have 200 plus 100 plus 50 plus ... Okay. Notice I'm not going to be nice enough to give you the formula like the book did. Probably won't on a worksheet or homework problem. Maybe the homework problems, but probably not on the test. Will I be nice enough to give you that formula? Okay, and so what you want to do is you want to check to see if a sum exists first. So step 1 is find r. Notice this goes ... forever, which is a really big difference between this and this, which says it goes to 16 terms. This is back to problem number 94 and 95. This one stops. Because it stops, a sum will always exist, because you're just going to add up the numbers to that many spots. What I'm looking at now is infinite geometric series. What happens if I just have ... forever? You notice it doesn't restrict it to a number of terms. It just has the ... and then nothing. Okay, so sometimes a sum exists for these, and that is if it's going down each time, you can tell that it will approach a number and actually have a sum. Okay, and what you want to do is find r first, and to do that you do 100 divided by 200, which is 1/2. Okay, and some of you guys are saying 0.5, and that's fine. Okay, and so what you want to do is see if it's less than 1. 1/2 is less than 1, so a sum exists. Okay, if this is the case, then we can use the formula to find the sum, and the sum formula is fantastic. Okay, it's the first term divided by 1 minus the multiplier ratio r. That's it. That's the whole formula. I love it. Okay, so the sum equals, the first term is 200 divided by 1 minus 1/2. Okay, and this is hopefully not going to shock you too much. 200 divided by 1 minus 1/2 is 400. Haha. So, linking that back to here, 400. Yes, this is approaching 400 as your numbers get bigger and bigger. So if I go out forever, I know that I will be a sum of 400. That's really as easy as it is. Okay, now example 2. Notice I'm a jerk. I didn't give you r. I didn't give you the formula. Okay, so step 1 is the same. Find r. 24 over 16, which is 3 over 2. You guys can put 1.5. I don't care. Okay, so 3 over 2 is greater than 1, so no sum exists. And that's it. You don't have to do anything else. This is like kind of a no solution situation. You don't have to go on to step 2. If no sum exists, then you're done. Okay, the last thing I want to show you in this problem is, what might this look like if it's in summation notation? Okay, so for this one, get my big sigma. Okay, so 0th term would be 400 times r is 1/2 to the n, and I want to tell it where to start and where to stop. My start is going to be 1, but my stop never happens, so I put infinity there. Okay, so this would give you 400 times 1/2 to the 1, 400 times 1/2 to the 2, and then you make a dot 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 to show that it goes on forever. Notice that matches that. Okay guys, that's it. That is pretty much the end of series. We are going to start working on binomial theorem after this. And I've cut your homework in half. Do not do any of the homework problems except for 123 to 129. Thanks guys.